In this lesson, we will be learning how to find the solution to exponential inequalities and also logarithmic inequalities such as these. If you have a pencil in your hand, please put it down. Watch me do it, learn how to do it, but then go back and do it yourself. You need the practice. Alright, problem number one, if I want to solve this, I need to get this exponential part by itself first. So that would be 13 is equal to 7 to the 2x power. Now if I want to get x out of the exponent, I need to rewrite this in log form. Start with the base, so that means log base 7. Now the other part, the 2x and the 13, will change sides. So the 2x will come over here and the 13 will go here. Last step, to get x by itself, I'm going to divide by 2. Okay, that is going to give me x equals all of this. Alright, now we want to put this in our calculator. However, there's no way to directly put log base 7 of 13 into a TI-30XS multiview. So, okay, that's denominator of 2 is still there. But I need to use the change of base formula to rewrite the numerator. So I could write this as log 13 over log 7. Okay, now I can put this in my calculator. Now I like to type these things in all at once. Okay, some people don't. Alright, so obviously I have a fraction. In the denominator, I've got 2. Alright, the numerator, this is the numerator. Okay, the numerator has a fraction in it. So, in the numerator, I make another fraction. And so now I could go log 13 over log 7. So that's why this is the answer, 0.66. Okay, please understand, here's another way you could have done it. If you don't like typing the whole expression in, or you make mistakes doing it that way, you could do it one step at a time. So I could do log 13 divided by log 7 and just hit enter. Okay, so far I've done the numerator part. Now I need to divide by 2. Just make sure you don't round. Just with all these beautiful decimals in your calculator, you can go ahead and hit divided by 2, and that will divide your previous answer by 2, and sure enough you get the exact same thing. So you do it whichever way makes you feel most comfortable. Now on this one, please remember that when you're adding logs, this is going to become multiplication. We're condensing. So this will condense down to log, and we're going to be doing x plus 1 times 4. Alright? And so addition condenses to multiplication. We'll have to do a little distributive property here. So this would be log of 4x plus 4 is equal to 2. Now I only have log on one side, so I'm not going to just cancel out the log. I need to rewrite this in exponent form. The invisible base here is an invisible base 10. So I'm going to start with that. Bring down your invisible base 10. Now these two parts will trade sides. This 2 is going to become the exponent, and 4x plus 4 will be over here by itself. Now of course 10 squared is 100, so I have 100 is equal to 4x plus 4. So subtracting 4 from both sides, it gives me 96. and then we will divide by 4. So that is 24. All right, take a quick glance and make sure that this is not extraneous. So I've got 24 plus 1, that's 25. You can't get a negative result when you plug it in, because that would be undefined. Okay, number 3. Now we're moving on to the real deal. Inequalities. Your first step here is to look at the related equation. Alright, in other words, just imagine that it was an equal sign instead of a greater than sign. Let's solve this, and that will give us a key value. It's all about like bases, so this would be easy to do. I could keep the 4 because I can write 16 as a base 4. It's 4 squared. That means that 2x must equal 2, which would mean that x would equal 1. Now this is not the solution, but this is a key value. So what I can do is I can go ahead and make my number line. Okay, and there is 1 right on my number line. Now looking back at the original problem, it's not equal to, it's greater than. So that tells me that I'm going to have an open circle. Okay? So that's my key value, because this divides the number line into 2 parts. Everything below -1, and positive 1, and everything above 1. So we need to pick a test value on either side. Okay? So, for example, I'm going to pick 0 for my test value. 0, of course, would be over here. And I'm going to see if this is a solution. If this is a solution, then everything over here will be a solution. If it's not a solution, then everything over here will be a solution. Okay, let's record what we do. So I am going to test x equals 0. Alright, you didn't have to pick 0. You could have used any value you wanted to, except for 1, of course. Alright, if x is 0, then the original problem becomes 4 to the 2 times 0 power is greater than 16. I'm going to put a question mark on that because I'm asking. I don't know yet. But 2 times 0 is 0, so that's 4 to the 0 power is greater than 16. Anything to the 0 power is 1. Is 1 greater than 16? How about no? Alright, that means 0 is not a solution. So this side over here is not part of the solution set. That means this side over here will be part of the solution set. Okay, so that means when I make my solutions, it will be everything from here on. Okay, so this is a graph of my solution set for number 3. Let's also write interval notation. So it's everything greater than 1. So I could say that's 1 to infinity. Alright, so this would be the solution in interval notation. Sometimes we'll have a square bracket on the 1, but not now because it's an open circle. Alright, it's strictly greater than. 1 itself is not part of the solution, only everything that's greater than. So we use a round parentheses to show that the 1 is not included. Oh, but yeah, I gotta get some more sleep. Anyway, let's go on to number 4. Again, look at the related equation. 1/3 to the x power is equal to 27. This will give us a key value. Understand that 1/3 is the same thing as 3 to the negative 1 power. And then I've still got the x up there. 27, of course, is 3 to the 3rd power. Negative 1x is the same thing as just negative x. I might as well just leave the negative 1. So negative 1x is equal to 3. Alright, but I just need x. So let's divide both sides by negative 1. That's going to give me x is equal to negative 3. So that is my key value. So let's graph that. Okay, so here is negative 3. Alright, I'm going to use a test value of 0. Yep. And of course 0 would be over here somewhere. So let's see if that is a solution. If it is, then everything on the right hand side will be a solution. If it's not, then none of these are solutions, and that means the solutions would be on the left. So let's check it out. Okay, so I'm going to test x equals 0. Well, that would make this 1/3 to the 0 power is less than or equal to 27. Well, anything to the 0 power is 1. Alright, question mark. Is 1 less than or equal to 27? Well, yes. Yes, it is. So, that means this side has the solutions, and this side does not. Okay, so when I draw the solution set, I'm going to start at the negative 3. Now see how this is or equal to? So this key value will be included, closed circle. And the solutions are clearly to the right. So there are the solutions graphed out. Now in interval notation, we're talking about negative 3 to infinity. We'll make the square bracket this time. Alright, negative 3 itself is included. It says less than or equal to. So negative 3 to infinity. Alright, number 5. Consider the related equation 2 to the x minus 2 power equals 32. Alright, now looking at the chart, notice how 2 and 32 are in the same row. Alright, that's because 32 is the same as 2 to the 5th power. Okay, so I can keep the base 2, but I can write this as 2 to the 5th power. That means I can set these exponents equal to each other. So x minus 2 is equal to 5. Adding 2 to both sides, I get x equals 7. That is a critical value. It's not the final answer, but it's a place to start. So let's make our number line. Okay, so here's 7. Now I need a test value. Now, I often pick 0. So you've seen me do that many times before. So I could pick 0 and put that in and see what that does. I could also pick 2, which is what I might do. Maybe I'll just do both real quick. If I put in 0, okay, imagine I put in 0. So test x equals 0. Well, that would mean 2 to the 0 minus 2 power is less than 32. Question mark. Alright, but that would mean 2 to the negative 2 power is less than 32. Question mark. Well, that means 1 over 2 squared, right, is less than 32. Question mark. Why did I put 4th power? Okay, but 2 squared is 4. So that would mean 1/4 is less than 32. Obviously 1/4 is less than 32, so that's a big old yes. So I tested 0, and yes, that was one of the solutions, which means no, over here this is not a solution area. Let's see, so this is strictly less than, no equal to. So we will do an open circle, and this time I'll draw my arrow going to the left because this is where the solutions are. Okay, in interval notation, this is negative infinity to 7. Alright, round parentheses because 7 is not included. That's why it was an open circle in the first place. Okay, so that was number 5. Let's check out number 6. Alright, log equations. Got to be a little careful with these logs. I'll explain why in a second. Let's start with our related equation. So look at log base 3 of x is equal to 2. Now, if I rewrite this in exponent form, I would bring down my base of 3, and then these two parts would change sides. So that would be 3 squared is equal to x. So that's 9. X is equal to 9. So I am going to draw my handy dandy number line. Okay, so here's 9 right here. Okay, that will be a closed circle. It says or equal to, so that means this borderline point will be included. So I'll put a closed circle up here. Okay, now I need a test value. Okay, I can't use 0 now. Alright, do you remember when we used to graph logarithmic functions? Okay, like this one. Logarithms have asymptotes, alright? Logarithmic functions have asymptotes. Vertical asymptotes like this one. And if you're dealing with a parent function like this one, you know, without any pluses or minuses in it, the asymptote is going to be the y-axis. Okay, it's going to be at 0. And so remember, an asymptote, the way it works is you can get closer and closer to it as you're coming towards it, but you can't actually touch it. Alright, the x value can never be, in this case, 0. Alright, the x values can't be 0. So that's why I can't use a test value of 0 because it's not part of the domain of a log function. Now also, let's look back at that graph again. Not only is this the asymptote, but the graph is not going past it. Alright, so it's not going to be 0 or anything negative. It's strictly going to be a greater than 0. So you have to remember the domain when we do log functions. Alright, the domain is just 0 to infinity for the parent function. Okay, so anyway, I could use a test value of 1, which is kind of my favorite to use. So that's what I will do. But please understand this. Let me go ahead and mark 0 down right now. 0 is the asymptote. Okay? I should put like maybe a dotted line right here or something. Alright? Remember that this is the asymptote. You can't go past here. There's nothing going on over here. Alright, anyway, back to business. Let's use a test value of 1. Okay, so test value of 1. Make sure you use the original function, not the exponent form or something like that. Alright, so I'm talking about log base 3 of 1 is less than or equal to 2, question mark. Alright, now I'm hoping you could just look at this and know that the value is 0. Okay, because the way you do a log is you say, 3 to the what power is 1. Well, anything to the 0 power is 1, so it must be 0. Okay, 0 is less than or equal to 2. Well, yes it is. That's a true statement. So that means yes, this is where my solutions will be. And no, there will not be any solutions over here. Okay, now be careful though when you graph this, because I'm going to graph to the left of 9, but bam, I can't go past the asymptote. I can't even touch the asymptote, which is why I will make this an open circle. Okay, so this is what the graph should look like. Okay, just like that. And of course the interval notation that goes with it is 0 to 9. Kabam. So there's no infinity over her. Alright, that's just for logarithms. Exponential functions have a domain from negative infinity to positive infinity. So we only have to worry about this when we're dealing with logarithms. Anyway, more practice with number 7. So again, watch out for the asymptote. So let's look at the related equation. Log base 5 of x is equal to 3. Rewriting this in exponent form, I would have 5 to the 3rd power is equal to x. Well, that is 125 is equal to x. So here's our number line. Here is 125, and here is 0. So just remember, 0 here is the asymptote. Okay, there's nothing going on over here. It's undefined. Okay, so keep that in mind. So I need a test value, and I'm still liking a test value of 1. Still going to go with that. Whoops, should have left it pink. Okay, so here I go. So I'm testing x is equal to 1. Alright, talking about the original equation. So this would be log base 5 of 1, sorry, not equal to anymore, is greater than, alright, using the original inequality, is greater than 3. Hopefully you know that this is 0. 5 to the 0 power is 1. By the way, if you were ever to forget this, or if you were to pick something other than 1, you could use the change of base formula, even on this. Alright, you could do log 1 over log 5. Alright, let's just do that one time and see what we get. Hold on, technical difficulties. Okay. So if I do log 1 over log 5, see how I get 0? So even if you didn't know it in your head like you're supposed to, you could still come up with the right answer. Okay, now this is a question mark on these because I'm asking the question. Is 0 greater than 3? I don't think so. 0 is not greater than 3. So that's a no. Alright, that means there are no solutions in this zone, which means the solutions must be in this area. Okay, we are not including the critical point. So I'll put an open circle and put my arrow to the right. Alright, because that's where the solutions are. So that means in interval notation, the solutions are 125 to infinity. Just like that. Open circle, rounded parentheses. Alright, that was number 7. Here comes number 8. Same thing. Let's start off with the related equation. Log base 4 of x is equal to -1. So if I rewrote this in exponent form, I would have 4 to the -1 power is equal to x. Okay, so 4 to the -1 power, that's 1/4. So that is our key value. So let's use that to make our number line. Okay, so this is 1/4. Now, don't forget, 0 is lurking over here, and 0 is the asymptote. Okay, this is still a parent log function, so the asymptote is still at 0. Alright, remember, there's nothing going on over here. It's this undefined area over here. Can't get over there. Okay, can't even touch the 0. Alright, because of the logarithms have an asymptote right there. Alright, so I still need a test value. Like I did before, I'm going to use a test value of 1. Now be careful. Does the 1, I keep missing, is the 1 going to go over here or over here? Yeah, 1 is bigger than 1/4. So I need to put it over here. Okay, that's my test value, so let's check it out. Okay, so that would give me a log base 4 of 1 is greater than or equal to -1. Okay. Log base 4 of 1. So this is going to be 0. Alright, just like before. 4 to the 0 power is 1. This is a question mark. So is this greater than or equal to -1? Question mark. Why, yes it is. Okay, -1 is further to the left on the number line, so 0 is bigger than -1. That means yes, the solutions are over here. Okay, that means there won't be any solutions over there. So that means, alright, and this time it'll be a closed circle heading this way, alright, which means in interval notation, need a square bracket this time. We're looking at 1/4 to infinity. Alright, that's number 8. I thought there was more. That was it. That's the end of the assignment. So I hope this was helpful, and I hope you didn't just copy off of me. I will see you on the next video.